Okay, so today we are going to do a kind of discussion moving forward in our solving equations. So we're going to get into solving multi-step equations. Now, what is a multi-step equation? Well, it's nothing that new. It's just previously when we looked at equations, we would have things like a over 4 equals 3, and then we could solve this just by performing one operation, invoking one of the properties of equivalence. Here, we might want to use the multiplicative property of equivalence, multiply both sides by 4, and we would solve the equation getting a equals 12. But not all equations can be solved by just applying one operation. And so that's what we're going to be getting into today, these equations that require multiple steps to solve. So with that being said, it's nothing new. Some of them are very, very close to what we have seen in the past. An example of an easy multi-step equation, one that doesn't require any new real thought, would be something like this. 6a plus 5a equals negative 11. And so, if we were to approach this, how do we go about solving it? So, the first thing we would do is we would add like terms. And really, what we would do is we would use our distributive property to rewrite the above as a times 6 plus 5, and that's going to give us, we'll keep this equals negative 11. These are going to be equivalent equations, and what we'll get is 11a equals negative 11. So this was us performing one, maybe two steps to get from here to here. And so now if we solve this here, this is still a multi-step equation because it took more than one step. And so we can solve this with just one more step. We use the division property of equivalence, divide both sides by 11, and we get a equals negative 1. So that would be a really easy example of a multi-step equation. Not all of our equations are going to be so nice, but that was kind of just like an easy beginning step. So let's see here. What would an example of a slightly more involved multi-step equation look like? Let's see. 18 equals 3 times 3x minus 6. Let's solve this equation for x. Okay, so the first thing I think we should do is use the distributive property to express this as 3 times 3, so 9x, minus 3 times 6, so minus 18. Okay, and so then all we would do is we would want to get rid of this minus 18, and so we would invoke the additive property of equivalence, and so we would add 18 to both sides, and then what we would get left with is 18 plus 18 is 36 equals 9x, and then negative 18 plus 18, 0, so this is where we can stop for that. Then, or not so much where we stop, but where we arrive from that. So we then can use the division property of equivalence to divide both sides of our equation by 9. We get 36 over 9 equals x. And so naturally we can rewrite this. What would 36 over 9 be? Well, that would just be 4. So we've solved our equation, we have for this x equals 4. And if we want to check ourselves, we can. Let's see. So 18 equals 3 times 3 times 4 minus 6. And so what's this going to be? Well, 3 times 4 is 12 minus 6. So all in all, that would be 6 inside of these parentheses. And so we would get, if we carried this equation over, 18 equals 3 times 6, which is true. 18 is 3 times 6. So this equation is satisfied when we plug in x equals 4. So good. We've solved our first kind of involved multiple step equation. So let's see if we can find another multi-step equation to look at and see what we can get. So let's solve another multi-step equation. Let's use negative 5n minus 8 times 1 plus 7n equals negative 8. So if we are going to solve this for n, the first thing we should do is kind of just a little bit of cleaning things up. So how can we get this left-hand side of our equation looking as neat as possible? So let's see here, probably keep that 5n right now, but we would distribute this negative 8 through these parentheses. Remember to keep that negative, so we get negative 8, and then minus 56n. And all in all, this is still going to equal negative 8. Now we can combine our like terms. So we're left with negative 61n minus 8 equals negative 8. Okay, so now we will be using the additive property of equivalence to rewrite this equation as following. Negative 61n minus 8, so we would be adding 8 to both sides. Just to clarify. And so negative 8 plus 8 is 0, negative 8 plus 8 is 0, and so we get negative 61n equals 0. So if we have a number, we'll rewrite this just to keep everything a bit clear. This might seem a little bit strange at first, but really we can still approach this the same way we've been approaching these. We want to get rid of this negative 61, so we just divide both sides of the equation by negative 61 using the division property of equivalence. And so 0 divided by negative 61 is 0, so we get n equals 0. Let's go through and check, and this shouldn't be too nasty to check. Negative 5n equals 0. Negative 8 times 1 plus 0. Negative 8 equals negative 8. That's good. We verified that we have solved this equation, and so we get n equals 0. Good. So, with that being said, let's take a second to talk about two other things. So, the first concept that's important, and it will be important moving forward, is an idea of consecutive integers. So what are consecutive integers? Consecutive integers are integers that have a distance between each other of 1. So let's see. Your book defines it as integers in counting order. Examples being things like 4 and 5. Those are consecutive integers. Negative 3 and negative 2. Those are consecutive integers. Notice that 5, 4 would not be consecutive integers. So be sure that you keep the order correct. This will more be a problem, I think, with negative numbers. So you wouldn't say negative 2, negative 3 are consecutive. You would say negative 3, negative 2 are consecutive. So just keep that in mind. So with that being said, there's also a notion of consecutive even and consecutive odd integers. That would just be something like 4 and 6, where we only examine the next even entry. And so -4, -2, those would be consecutive even numbers. Consecutive odd numbers are going to be very similar. They would just be the next odd number. So 5 and 7, -11, -9. Okay, so let's think of an easier way of writing these out symbolically. So if we have a number n, what would the consecutive integer be for n? Well, that would just be n plus 1. Good. So if we have a even integer, let's call it a. Let me get rid of that. Let's call it just a. So what would the consecutive even integer be if a is even? And it would be a, not plus 1, but plus 2. So a and a plus 2 would be consecutive even integers if a is an even integer. Now for an odd integer, let's say b, the consecutive integer that is odd, so the consecutive odd integer would be b plus 2 as well. So this would be consecutive integers, consecutive even integers, and consecutive odd integers, provided that a is even and b is odd. So let's kind of use that a little, but I guess first it's probably a good idea to define number theory. Number theory is just the study of numbers and the relationships between them. So a lot of what we're moving on to right now is some introductory number theory. So with that being said, let's kind of solve a problem that uses a little of this consecutive integers, and it gets us into a little bit of number theory. So if we want to find three consecutive even integers who sum up to be 32, so we want three consecutive even integers that sum up to 32, how do we do that? So we know that we don't, I guess we don't know what the value of these integers are, and so we don't know what the first one is. We'll start out by saying, what is this first integer? Well, we don't know, but we do know the form of the next integer. Since we are looking at even integers that are consecutive, we know that that next integer will be n plus 2, and the integer after that will be n plus 4. This is to say, really, we are looking for three consecutive even integers, so we don't know three values, but if we were to say this is x1, this is x2, this is x3, where we don't know what x1, x2, and x3 are, that would be correct. However, we do know that they are all consecutive, and so with that, we're able to write x1 is just our unknown, and then x2 in terms of x1, and x3 in terms of x1. So we are able to use the definition of consecutive to write these as just one unknown instead of having three unknowns. Okay, so if we were to write n plus 2 plus n plus 4 equals 32, so we could solve for n. And so we would get 3n, if we just group our terms, plus 6 equals 32. So this is a multi-step equation that we can now solve. So 3n equals 32 minus 6, because we can just use the subtractive property of equivalence. And so that would be 20, let's see, 6. Now, here we come to an issue. If we divide both sides by 3 to use the division property of equivalence, we get n equals 26 over 3. So let's rewrite this in its simplest terms. And so that would be 8 and 2/3. So we have an issue. There is no way to write 32 as a sum of 3 consecutive integers, because if we let these integers be consecutive and we solve for this unknown, we don't get an integer. And so we are able to say that this problem is actually unsolvable. So if we were to take and tweak this a tiny bit, let's say instead of solving for 32, let's try 30. So we want 30. We know 30 is the sum of 3 consecutive integers. Let's kind of take this from the top. So we know 30 is the sum of 3 consecutive even integers, and so we know this is the equation we can be using. However, since x1, x2, and x3 are all consecutive, we can say x1 equals n, x2 equals n plus 2, because it's consecutive and even, and x3 equals, well, really it equals x2, so n plus 2 plus 2. So that would just be n plus 4. So we can rewrite x1, x2, and x3, getting rid of 2 of the unknowns and leaving us just with n plus 2 plus n plus 4, like how we had. And so now we can solve this multi-step equation in order to find out what n would be. So we add our like terms, so we get 3n plus 6 equals 30. So now we subtract 6 from both sides, and we get 3n equals 24. Now, if we divide both sides by 3, we get n equals 8. So we now have the value we need, and we can check ourselves. So x1 is 8. So 8 plus x2 would just be 8 plus 2, so 10. And then x3 would be 8 plus 4, so 12. And let's see, 10 plus 12, 24, 8 plus, my bad, 10 plus 12, 22, 8 plus 22, that'd be 30. So we're good. So hopefully that, made sense. If you have any questions about solving multi-step equations or consecutive integers, consecutive even integers, and consecutive odd integers, please let me know. Thank you for watching.